All right, let's get right into it. Today, we're talking about a really cool new method called WebSailor. And what it does is, well, it teaches AI how to surf the web in a way that feels almost superhuman. It's a completely new way of finding information, especially for the kind of AI that's open and accessible to everyone. You know that feeling, right? You're digging through page after page of search results, and you just can't find that one thing you're looking for. The internet is basically an infinite ocean of data, and it turns out that feeling of being lost isn't just a human problem. It's a massive, massive challenge for AI, too. So let's introduce the hero of our story today, the web agent. Just think of it like an AI that can open a browser, use search engines, and basically act like your own personal, super skilled research assistant. But as we're about to find out, there's a huge difference between a regular web agent and a great one. And this brings us right to the core of the problem. For a long time, there's been this giant wall. On one side, you have the open source AI agents that anyone can use. And on the other, you have these incredibly powerful proprietary systems that big tech companies keep under lock and key. And the performance gap between them is just enormous. I mean, just look at this. This chart shows you exactly what I'm talking about. There's this super difficult test called BrowseComp, and it's designed to push these agents to their absolute limits. And what happens? Well, the open source models, they score pretty much zero, nothing. Meanwhile, the big proprietary systems, they're getting over 50% right. That's not a gap, my friends. That is a chasm. So you might think, well, the open source models just aren't as good. But here's the twist. The problem isn't really the AI model itself. It's how we've been training them. We've been teaching them to solve problems that are, frankly, way too simple. We're teaching them to play checkers when the real world is a chaotic game of 3D chess. And this is where things get really interesting. The researchers behind WebSailor had a wild idea. What if, to get superhuman results, you need to give the AI superhuman training? The secret, they figured, was to create a kind of training fog, tasks that are so incredibly complex and confusing that they force the AI to think in ways that we humans don't. So they broke it down into 3 levels. Level 1, that's your basic Google search. Super simple. Level 2 is a bit more involved, like following a recipe, you know the steps. But level 3, well, that's the fog. It's this tangled mess of facts and clues with no obvious path forward. And that, right there, is the key to unlocking this new level of performance. Just try to wrap your head around this question. This is a real example of a level 3 task. You've got a lyricist with a local award, a composer from a school in Colombia, and you have to find a single musical piece that connects them. There is no single search query on Earth that's going to solve this for you. You have to jump from clue to clue, build connections, and explore. It forces a totally different kind of thinking. They gave this incredible dataset a name, Sailor Fog QA. It's a whole collection of these computer-generated, ridiculously hard questions. They're literally built from the ground up to be almost impossible, which forces the AI to invent brand new ways to solve problems. Okay, so you have this incredibly difficult training course, but how do you actually get an AI to learn from it without just giving up? Well, the answer is a really clever 2-stage power-up. It's like a 1-2 punch for AI training. First up is the cold start. Think of this as giving the AI a good starting map, showing it the basic outlines of what a good search looks like. Then comes the second stage, the policy polish. This is where they let the AI off the leash. It uses a smart kind of trial and error to explore beyond the map, finding its own shortcuts and more clever paths that we never would have thought of. So, after all this intense training in the fog, what happened? Did it actually work? Well, the results are, to put it mildly, absolutely stunning. That massive capability gap we talked about, get ready to see it slam shut. This right here tells you everything you need to know. The WebSailor agent running on a small 7 billion parameter model, which is tiny by today's standards, just look at it. It more than doubles the performance of other agents that are running on models over 4 times its size. This proves it's not about the size of the AI brain, it's about how you teach it. Let's just sit with that number for a second, 6.7%. On a test where similar models were getting less than 3%, this little guy comes in and blows them away. It's the ultimate proof that a smarter training technique is way more powerful than just throwing more computing power at the problem. It's smarter, not just bigger. And this wasn't just a one-time thing. Across the board, on all sorts of different challenging benchmarks, the WebSailor models are just crushing it. They set a whole new state of the art. I mean, look at the Chinese benchmark, the BrowseComp CH. The bigger WebSailor model gets a score of 30.1. The next best open source competitor is at 7.3. It's a massive leap. And now, for the grand finale. This is really the climax of the entire story. On that tough Chinese benchmark, WebSailor doesn't just get close to one of the top-tier closed-off proprietary systems, it actually beats it. That gap we started with, consider it closed. This is a monumental moment for open source AI. So, okay, this is all very impressive, but what does it really mean for the rest of us? Why does this matter? Well, this breakthrough is about so much more than just building a better search engine. The implications here are huge. First off, it helps democratize AI. It puts truly elite capabilities into the hands of the open source community. Second, it's a massive win for the smarter, not bigger approach to building AI. And third, and this is maybe the most exciting part, it opens the door for us to use these AI agents to attack really complex research problems that have been completely unsolvable for us humans. And that really leaves us with one final fascinating thought. Now that we have a way to train AI to think and reason in ways that are, for all intents and purposes, superhuman, what should we ask it to do? What are the great, big, unsolvable questions that we should point this new intelligence at next?